Hello and welcome to another video. So today we'll discuss the structural geology question of CUET. So we'll start from 2020 question. So first question is your zone of broken and crossed rock fragments of varying size in which the bulk rock consists of fine powder are called as. So zone of broken rock means there should be a brittle rock. Broken and crossed rock that indicates your you can say brittle rock. So these type of rock basically found in your faulted region or faulted terrain, you can say, along the fault plains. These are called as your fault rocks. So a broken rock, that means brittle. It has bulk of the rock consists of fine powder, that means that indicate matrix. So this is the table that indicates different type of rock that found in a faulted zone. So they are basically classified into two types: rock without primary cohesion, rock with primary cohesion. So your fault breccia, fault gauge, these are your rock without cohesion. Then with primary cohesion, we have two types. Basically, majorly you can say two types. One is your non-foliated, one is your foliated. So in non-foliated category, we have microbreccia, cataclysite. Then foliated category, we have myelonite. And in glassy matrix condition, it is your pseudo trachyllite. So pseudo trachyllite, then these microbreccia and fault gauge and fault breccia, all are your, you can say, brittle rock. Only myelonite here is a ductile rock. Next comes to the question, zone of broken cross rock. So these are your, you can say, broken rock. Those are brittle, where they are classified on the basis of their matrix content. Where fault breccia, which have lesser matrix, less than 70%, more than 70% fault gauge. Similarly, for cataclysite, it has more matrix percent than microbreccia. So in question, we have to choose that should be a brittle rock and which have more matrix percentage. Among these options, your fault breccia has matrix percentage, but it is less than fault gauge. So fault gauge will be the correct answer here. Pseudo trachyllite, it is brittle and its main characteristic that it is indicative of ancient earthquake. Why it is called as it is produced during the earthquake shock. So answer will be fault gauge. So this is a very important table. So just try to remember all the things. So these fault breccia, microbreccia, fault gauge, cataclysite, pseudo trachyllite. The all are your brittle. Only myelonite is your ductile. So myelonite further classified on the basis of their matrix percentage. So answer will be fault gauge. So the next question, it is given a cessation of deposition of sediments during which no strata were deposited or a gap in the rock record is known as. So if there is a continuous deposition of sediments, so during that deposition, sometimes there is maybe a period of erosion or period of non-deposition, which is called as your unconformity. So in cessation deposition of sediments during which no strata were deposited or gap in the rock record is known as. So these are called as your unconformity. So basically the time gap is also called as hiatus. So it can be called as your hiatus. Angular unconformity also signifies the same thing. If there is a cessation of strata or there is cessation of deposition, but it includes always a technique activity where the strata, the lower strata, the older strata, you can say, they are tilted or folded. So this also indicate an time gap, but more appropriate answer here will be hiatus. So then a line joining points of equal stratigraphic thickness, what we called Iso height, it indicates equal rainfall. Isohaline, it indicates equal salinity. That means line joining equal salinity, line joining equal rainfalls. Isopachite, this is indicates equal thickness. So line joining points of equal thickness, that is called as your isopachite. The answer will be C. Then contour, it the line that joins equal elevation. So answer will be isopachite. Next comes to angle between the fault plane and the vertical. So now see, this is a fault. So this will be your fault plane. So any inclined plane, it has a deep, that is the angle measure from the horizontal, or you can say the angle measure on a vertical plane from the horizontal, that is called angle of inclination, or you can say deep. So this will be the deep of the fault plane, which measure from the horizontal. Now this is the inclined plane, and this is called as your throw, this is called as your heave. Throw is your vertical displacement, heave is your horizontal displacement of a fault plane. Or you can say there is an inclined fault plane, the vertical component is called throw, the horizontal component is called as your heave. So angle between the vertical component and fault plane, that is called as your head, that is called as your head. This is your deep and this is your head. The answer is asked about fault plane and the vertical, this will be head. So always remember, head plus deep is equal to 90 degree. Head plus deep is always 90 degree. So answer will be head. So heave is the horizontal component of the fault plane, throw is the vertical component of the fault plane. This question is structure formed where successive wedge-shaped beds extend further than the margin of the underlying bed is known as. So these type of deposition that occur, this type of structure you will find in marine condition, or you can say marine transition or regression condition. So here it is said ki wedge-shaped bed. Now suppose this is the bed, this is the lower bed, you can say this much. So during your transgression, the sea or you can say coast or sea, it will move or displace towards the land region. So that's why the deposition will advance in the direction of the land. So that indicates ki successive wedge-shaped bed extend further than the margin of the underlying bed. Suppose this is the underlying bed, so the overlying bed, they extend beyond the margin of the underlying bed. So this condition occur during translocation, which is called as your on-lap. Then off-lap, similar thing but occur during marine regression. You can see here, during regression, successive bed that deposited towards the sea. So they cannot extend beyond the position or beyond the lower bed. Say they deposit towards the sea. There is also a successive deposition, but it is towards the sea. So in case of regression, there will be off-lap. In case of transition, there will be on-lap. And the top of the bed, they are called as your top lap. And down lap, you can take the example of your it is a clinoform type of deposition, where you can take the example of four-state bed. Four-state beds are called as your down lap, which extend or that inclined and touch the floor. So here answer will be on lap. Next, the fold in which the axial plane is essentially horizontal. So this will be the axial plane of the fold, which divide the fold into two similar halves. So the axial, according to the axial plane, we can classify the fold into different types according to the, you can say, attitude of the axial plane. So we have recumbent fold where the axial plane is always horizontal. So the answer will be recumbent fold. Then we have vertical fold. So vertical fold is like this, where the axial plane is vertical, also the fold axis is vertical, both vertical. Then a reclined fold, it is a special type of fold where the deep of the axial plane and plunge of the fold, they are in the same direction. So always remember, in case of reclined fold, deep of the axial plane equal to, you can say, plunge of the fold axis. So it is only possible in case of when the fold axis direction is perpendicular to the axial plane direction. In that case, it is possible that the amount of deep equal to plunge of the fold axis. That we have studied in case of your deep and your plunge condition, where any bed, if it has same amount of, if any suppose line on a bed, it has same amount of plunge as the deep, then remember the plunge direction of the bed and deep plunge direction of the axis or line, you can say, or deep direction of the bed, they are perpendicular to each other. They are in same direction. So in reclined fold, deep of the axial plane equal to plunge of the fold axis, where the axial plane is inclined and the fold axis is inclined. Then isoclinal fold, it is a type of fold that depends upon the interlimb angle, where the interlimb angle is 0 degree, that is called isoclinal fold. So 0 degree if it is, then isoclinal fold. 0 to 30 degree, it is called as your tight fold. 30 to 70, it is called as close fold. 70 to 120, it is called as open fold. 120 to 180, it is called as gentle fold. So these classification is on the basis of interlimb angle. So according to the question, where axial plane is essentially horizontal, it is called as recumbent fold. In vertical fold, the axial plane is vertical, and this is, you can say, upright fold, where axial plane is also vertical. So there are three fold, remember, one is recumbent, one is vertical, one is upright fold. Recumbent axial plane is horizontal and fold axis is also horizontal. It will be like this, both fold axis and axial plane, those are horizontal. It is also come under category called as neutral fold, where it is closed sidewise. Then vertical fold, both are vertical. Then the upright fold of axial plane is vertical. Then reclined fold, both are inclined. Then your isocline, it is another category that we have discussed. Then angle between a straight line and the horizontal in an inclined plane. Angle between a straight line and the horizontal in an inclined plane. So the horizontal, it is called, suppose this is a plane, the horizontal, it is indicates the strike line. So this will be the strike line, and this line, you see, it is a straight line. This is a line on the bed. So the angle between the line and horizontal, this is called as your pitch. This is called as your pitch. And the angle of inclination of this line, it is called as your plunge. It is called as your plunge. So answer will be pitch. Head we have discussed, it is the angle between the vertical and it is your fault plane. Pitch and plunge, these are used, pitch and plunge, that are used to determine the attitude of a line. Any linear structure, they are defined, their attitude defined on the basis of pitch and plunge, and any planar structure, their attitude defined by dip and strike. So dip is the angle of inclination of a bed, and strike, it is the intersection of an inclined bend with the imaginary horizontal. So this is the strike line, and this can be the dip of the bed. So deep, there are two types of deep. One is your true deep, another is your apparent deep. So true deep always measure perpendicular to the strike. This is the angle measured perpendicular to the strike, and true deep is the maximum deep of a bed. So if you measure deep in other directions, they all are called as apparent deep, which is always less than the true deep. So this will be the, you can say, true deep direction. This is strike direction. All other directions in between true deep direction and strike direction are called as apparent deep direction, where the apparent deep amount will be less than the true deep amount. So here the question asks angle between straight line and horizontal. So it is pitch. Plunge, you have understand, it is the angle of inclination of the line, that is plunge. And apparent deep, it is the deep measured other than the true deep direction of a plane, which is always less than the true deep. So apparent deep amount is always less than the true deep amount. Next comes to 2021 questions. Direct stress. So direct stress, it is always remember act perpendicular to the surface, act normal to the surface. That is called direct stress. If it is acting parallel, then it is called shear. And inclined oblique are same thing. So if it is acting inclined, then it will be resolved into two components, three components you can say. One normal stress, two shear stress. One can say normal stress is your direct stress. So answer will be normal. In which of the following are the limbs dipping away from each other? So you have two types of fold here on the basis of this condition. One is your antiform and there is your synform. One is your antiform, another synform. So in case of antiform, the limbs dip away from each other. In case of synform, the limbs dip towards each other. So in which of the following are the limbs dipping away from each other? So synform, in synform the limbs will dip towards each other, so it will be incorrect. Then syncline, another type where you can say the limb will dip towards each other, but the younger rock will be present at the core and older rock will be present at the periphery. So in that case, that is called your syncline. It is called your syncline. Then comes to these two fold: anticlinal fan fold, synclinal fan fold. So fan fold, it is like this. So in fan fold, the limbs are overturned. Both the limbs are overturned. So as both the limbs are overturned, so see, this is a normal limb. So it is dipping in this direction. If it is overturned, the dipping direction will change. So there are two types of given here: anticlinal fan fold and synclinal fan fold. So this is anticlinal fan fold. This is synclinal fan fold. So in case of antiform, we have seen that limbs are dipping away from each other. But if it is overturned, then the dipping direction will change. So in case of anticlinal fan fold, the limb will dip towards each other. In case of synclinal fan fold, the limbs will dip away from each other. So the answer will be synclinal fan fold. Because in fan fold, both the limbs are overturned, so the dipping direction condition will change. Next comes to slaty cleavages. Slaty cleavages, these are, can say, produced because of compaction or directed pressure condition where there is no folding involved. So slaty cleavage are formed during, can say, on deformed stage. So slaty cleavage, it has a characteristic that the spacing between the cleavage planes are very less. It is called as a continuous cleavage. If any foliation that produce cleavage is a foliation, if any foliation is produced and after formation of the foliation, if it undergoes another phase of deformation, that is folding, then it will call as a granulation cleavage. So that's why slaty cleavage cannot be formed by any of the folding event. So answer will be on deformed state. If it is deformed, then it will produce a granulation cleavage. So next comes to another question, that is your conjugate fold. So fold, what is conjugate fold? So it is a double hinged fold. It is like this, it is a double hinged fold where the hinges are sharp. There is another double hinged fold where the hinges are rounded, is called as your box fold. So this will be box fold, this will be your conjugate fold. Okay, let's see the options. Fold developed in many stages. So it is not produced by many stages. Fold in axial surface which is deep towards each other. So if you put axial surface here, so there will be two axial surface here. One is like this, another is like this. So here you can see the axial surface will deep towards each other. So this will be the correct option. Fold with variable axial surface. Not variable, they have two axial surface, they are dipping towards each other. Fold in which both the limbs are overturned. So this is not an overturned fold, where the limbs are normal. Next comes to strike joints. So strike joints are so strike joints, it is a type of joint, you can say, where the strike of the joint should be parallel to the strike of the country rock. The strike joints, it can be, you can say, vertical joint or inclined joint, when the strike of the both vertical and inclined joints have strike parallel to the strike of the country rock. So this, you can say, these are strike joint. This is a country rock. This is one country rock. The strike of the joint, it is parallel to the strike of the country rock. If you can say it is inclined, it is called as your oblique. And if deep of the joint, it is parallel to the strike of the country rock, it is called as your deep joint. This comes to tear fault. So tear fault, it is a type of fault. It come under strike slip fault, where it cut across any country rock. So it will be strike slip fault. See, this is a tear fault where it upset the structure. It upset the structure. So that is it is a characteristic strike slip fault, you can say. So tear fault is a strike slip fault. So all other type of fault we'll discuss in upcoming questions. Next, when the two sets of beds separated by an unconformity and are not parallel is called as your. So there are different types of unconformity here given. One is angular unconformity, where the horizontal bed are deposited against inclined bed. So where two beds are separating but they are not parallel, so it will indicate an angular unconformity. So answer will be angular unconformity, where inclined beds, horizontal beds are deposited over inclined beds, you can say over folded beds. So in case of angular unconformity always indicates a phase of tectonic activity or deformation activity. Then we have disconformity. So this is a type of, you can say, parallel unconformity. It is otherwise called as a parallel unconformity, where there is parallel relationship between upper and lower side of bed, like this. This is your unconformity surface. or you can say erosional surface. So in case of parallel unconformity, the presence of unconformity is indicated by the presence of an erosional surface, which is called as unconformity surface. And in case of angular unconformity, the angular relationship itself indicates the presence of an unconformity. The non-conformity and heterolithic conformity are both the same. Heterolithic conformity, it is produced when any sedimentary bed deposited over any igneous intrusion or metamorphic rock. So in any sequence, if you will find sedimentary bed are deposited over igneous intrusive body or over metamorphic rock, then it will indicate an unconformity, which is called as a heterolithic. Because of different type of rock involved, it is called as a heterolithic. So answer will be here angular unconformity. So let's come to the table match. So pitch you will know it is angle between a line on the bed and the strike of the bed. So angle between, you can say, linear element that lies in a given plane and the strike of the plane. So pitch with this. Then plunge, it is the angle of the linear element with Earth's surface imaginary vertical plane. So you can say it is the angle of inclination of a line, that is plunge. Then strike which is azimuth of the horizontal line in a dipping plane or the intersection between given plane and the horizontal surface. So this is called as a strike where any inclined bed that meets the horizontal, that is called as your strike line. Then foliation, it is a ductile structure where you will find parallel alignment of platy or flaky minerals within a rock with some cohesion in between the platy or flaky minerals. So foliation, that's why called general term of surface that occurs repeatedly in a body of rock. So these are, you can say, ki cysto structure, they present like this. You can think of a book, or if you have seen mica, they show foliation. So they arranged layer by layer in a repeated manner. So that's why the foliation will be correct for this option. So answer will be in C. A is your third. There is only one option. It will be A. B, I, C your fourth, D your second. So option A will be correct. Let's go to so next question, when do drag fold forms? So drag fold, the keyword suggests it is produced by dragging, or you can say shearing. So when an incompetent bed it's sandwiched between two competent bed. This type of scenario where there will be shearing, you can say, then the incomplete bed can produce fold. So when we can say when first option, when a competent bed slide past another competent bed, it is not a feasible condition. When an incompetent bed slide past another incompetent bed, it is not feasible. So when this is your option, when a competent bed slides past an incompetent bed, if this will slide past over the incompetent bed or shear over the incompetent bed, then the incompetent bed will produce fold, that is called as drag fold. So option C will be correct. Next question, joints are often evenly spaced. So most of the joint, you can take the example of mural joint, master joint, they can be evenly spaced. So formation of joint relieves tensile stress for a critical distance. The width of the zone or either side of the joint in which there has been a decrease in tensile stress determines the spacing between the joints. So this is the assertion, this is the reason that joints are often evenly spaced. So joints can be evenly spaced and you can take the example of mural joint, where you will get three sets of joint that they're equally spaced, and they can dissect the rock into cubital mass. You can take the example of master joint, which produce rectangular blocks where the joints mostly evenly spaced. So the spacing that depends upon the tensile stress relief. So formation of joint relieves tensile stress. So if you can say can produce by tensile stress, can produce by compressive stress. So most of the joint are produced by tensile stress, where if you put pressure or put stress on a rock, suppose we will take tensile stress. So the rock will withstand for a critical stress, then it will break. So the amount of stress will determine what will be the width. So width of the zone on either side of the joint in which there has been a decrease in tensile stress determine the spacing between the joints. So the amount of tensile stress is always that controls the spacing between the joints. Well, the joints will be very closely spaced or it will be widely spaced. So both A and R are true, and R is the correct explanation of A. So you can remember this thing where the spacing of the joint that depends upon the amount of tensile stress. So according to Anderson theory of faulting, normal faulting occurs. So according to Anderson theory, remember always, if sigma 1, sigma 2, sigma 3. These are very important. Sigma 1 vertical, this is vertical, this is vertical. Then normal, this is strike slip, this is reverse. This is very important. Most of the questions are asked whether if sigma 1 is vertical, which type of fault will produce. If sigma 2 vertical, which type of fault will produce. So if sigma 1 vertical, then it is normal fault. If sigma 2 vertical, it is strike slip fault. If sigma 3 vertical, it is reverse fault. So when sigma 1 is vertical, the other two are horizontal. That means sigma 2 and sigma 3 are horizontal in case of normal fault. In case of strike slip fault, sigma 2 is vertical, other two sigma 1 and sigma 3 are horizontal. In case of reverse fault, sigma 3 is vertical, other two sigma 1 and sigma 2 are horizontal. So in case of normal fault, we know sigma 1 will be vertical. So let's analyze the options. Sigma 1 and sigma 2 are horizontal, sigma 3 vertical, it is the case of a reverse fault. Sigma 1 and sigma 3 are horizontal, sigma 2 is vertical, it is the case of strike slip fault. Sigma 2 and sigma 3 are horizontal, sigma 1 is vertical, this is a case of normal fault. So C will be the answer. So see, next question, identify the fault in the given diagram. So in this diagram you can clearly see this is a strike slip fault. So how will know whether it is a sinistral or dextral? So you stand facing the fault plane, you have to stand facing the fault plane. If your right side move towards you, then it is right slip fault. If the left side move towards you, that is left slip fault. So like this you can see. Suppose I am facing the fault plane, if this is my right hand, it moves towards me, it is your right slip fault. If left side move towards me, it is your left slip fault. Right slip fault is called dextral, left slip fault is called sinistral. And you can see this block move towards the observer, it is the right side, so it is called as your right slip fault. So answer will be right slip fault or dextral. Next, dash map place rock in their presumed position before folding and thrusting. That means it indicates a pre-deformed condition of the rock. So this type of map is called as planispheric map, where it represents the pre-deformed condition of the rock. Suppose the rock is faulted. So what was the position before the faulting and folding? So that map indicates planispheric. Paleogeographic, it is ancient geographic condition. Paleogeologic, it is can take any ancient geological condition of any region. Paleotechnic also same. So these all indicates the ancient condition of any region. A planispheric, it indicates the ancient condition or pre-deformed condition of the rock. Next question, the maximum deep of a bed is measured to be 20 degree. Maximum deep means that is true deep. True deep is your 20 degree in the direction of north 30 degree west. So let's take this is your north. So this is north 30 degree west. So this will be the true deep direction. This will be the true deep direction. So in this direction we have a deep of 20 degree. What will be its strike direction? So if this is the true deep direction, then any line that is perpendicular to this will be the strike direction. So this will be the strike direction. If it is north 30 degree west, so this will be your 60 degree. You can say north 60 degree east, north 60 degree east, or you can take also south 60 degree west, because it is not indicate any particular direction. South 60 degree west, north 60 degree east, it will be incorrect. Sorry. South 60 degree west, north 60 degree east, it will be correct. South 60 degree west and north 60 degree east, it will be the correct answer. This is incorrect, this is incorrect. So answer will be north 60 degree east and south 60 degree west. Then comes to types of fold. Recommend, we have discussed that in recommend fold the axial plane are horizontal. So axial plane is horizontal, that is recommend fold. Then chevron fold, it is a type of fold where it has sharp hinge and straight limb. It is like this. Hinges are sharp and limbs are straight. So hinges are sharp and angular. That is your chevron fold. Then overturned fold. So one of the limbs dip more than 90 degree. And it will be like this. This is one normal limb, another overturned limb, both dipping in the same direction. This is called as your overturned fold. This side is your normal limb, this side is your overturned limb, which is bent more than 90 degree. So axial plane is inclined, limbs dip in the same direction. That is a characteristic of overturned fold. Then box fold, we have discussed. It is a broad flat crest with two hinges. It is like this. So it has two hinge and broad flat crest. So answer will be A third, B is your 1, that will be C is your 4th, D. The option C will be correct. In a structural mapping, the trend refers to azimuth of a line and the azimuth is measured. Please remember, azimuth measured from a fixed geographic direction. So usually we always take that direction as north and it is measured in a clockwise direction. Suppose we have a line here, so azimuth will be this angle. So it is measured in a clockwise direction from the north, and azimuth always represent in triple digit. So answer will be in degree clockwise from the north. Then comes to low angle reverse fold are also popularly called as. Simply it is very common question. It is called the thrust fault. Low angle reverse fold are called as thrust fault. I can say low angle normal fault. Called as your lag fault. And transform is a type of strike slip fault, dextral is a type of strike slip fault, thrust is a reverse fault, napping is a type of structure where the lower bed slide past over the upper bed. So thrust is a type of, you can say, nappe. So thrust fault. So these condition where this will slide over, this bed will slide over this lower bed, so it is called as your nappe. When it comes to horizontal depositional surface separating relatively young strata above from the older steep dipping strata. So I have discussed this condition indicates an unconformity where there is a age gap. If there is angular relationship between the upper and lower bed, so it will be considered as angular unconformity. Because non-conformity, it indicates heterolithic unconformity. Disconformity is a parallel unconformity where there is a parallel relationship between bed where there is no steeply dipping strata present. So angular unconformity, it produces an age gap and also include an tectonic activity where inclined horizontal beds are deposited over inclined beds. Next, see, in context of geological mapping, the line of dip. The line of dip, it is the inclination, you can say. So it is at angle 180 degree to the line of the strike. So always remember, the line of dip, it is always perpendicular to the strike line. So that means it is an angle 90 degree to the line of the strike. So the true dip direction, or you can say the dip direction, it is always perpendicular to the strike direction. Then on a geological map scale, we have 1:50,000. The aerial distance between two outcrop is measured 1 centimeter. What will be the real distance? So here 1:50,000 means 1 centimeter is equal to 50,000 centimeter. 1,000 meter, 1 centimeter will be 50,000 centimeter. So 1 centimeter on the map, that is 50,000 centimeter on the ground. So map distance, if it is 1 centimeter, then ground distance in meter it is asked, it will be 500 meters. It will be 500 meters. Faults in the field. So these are criteria of, we can say, recognition of the fault. So fault is a large structure, so you cannot see the, you can say, foot wall, hanging wall, like this structure. You have to look for the different structure like slick and slides or other structure on the fault planes to identify any fault or identify the presence of any fault. So there are different criteria that helps to recognize fault in the field. So one is your presence of slick and slide. Slick and slide, these are, you can say, line that produced because of relative movement of the fault blocks. So this is used to determine the fault presence of chatter mark. Chatter mark, it is a type of marking like this concave mark, which you have studied in case of your glacier condition in continental ice sheet, where it, when a continental ice sheet will move, it will produce crescentic gauge on chatter mark. So these are indicative of movement of blocks. So chatter mark can also indicate the presence of fault. So chatter mark can found in fault and found in both glacial condition. Presence of breccia, that we have discussed in past question, that the fault breccia, fault gauge, those indicative of fault zone rock. So they always indicate the presence of a fault. Then truncation or offset, that is in tear fault, you will say offset. So that also indicate the fault. So all the four that indicates the presence of fault. So you can remember these things. So these are the structure that helps to recognize fault in the field. So answer will be C, A, B, C and D. So next comes to another question. The hanging wall moves, So next comes to another question, a normal slip fault. So normal fault, it is a fault, you remember, where the hanging wall will move downward with respect to foot wall, or foot wall will move upward with respect to hanging wall. So let's see, the hanging wall moves down with respect to foot wall. This will be the correct option. That is normal fault. The hanging wall moves up with respect to foot wall, it will be reverse fault. So how will determine hanging wall and foot wall? So always remember, the plane, the block that is above the fault plane is your hanging wall, below the fault plane is your footwall. Next question, in a geological mapping, the orientation of a line in space. So we have discussed this. The orientation means the attitude of line. It is represented by trend and plunge, or you can say pitch and plunge. And if it is a plane, then it is represented by strike and dip. So your answer will be trend and plunge. Next, which of the following about joint is correct? So they are reasonably continuous through going planar fracture. So joints once produced, they can continuous for longer distance. So that's why they can be reasonably continuous and through going planar fractures. So it will be correct. They display systematic prefermentation. So we have discussed in different type of joint, the strict strike joint, deep joint, oblique joint. So they have preferred orientation. They can be observed on scale centimeter to tens of hundreds of meters. You can find micro joint, you can find larger joint. So they say so apparent movement along the surface. If there is apparent movement along the surface, so the joint will become a fault. So this will be incorrect. All other three are correct. So it will be A, B, and C. Option B will be correct. So next question, the ratio of the resisting forces of the to the driving force. So remember, this is important question which is called as a safety factor. So answer will be safety factor, that is resisting force divided by driving force. So there is no translation factor or sliding factor, but shear strength you can calculate C plus tan psi sigma is equal to then types of fault. Strike fault. Let's see what are the different type of fault here. And see. This is normal, this is reverse, but there are three type of fault you can calculate on the you can classify on the basis of rake of the net slip, that is strike slip, deep slip, and oblique slip. So in case of strike slip, you can see the rake. What is rake? It is the pitch, you can say. So these are, you can say, slick and slides. The angle between slicked side and fault plane, that is called as rake or pitch. If rake is 90 degree, it is deep slip fault. If rake is 0 degree, this is the strike of the fault. If rake is 0 degree, then that is strike slip fault. If rake is between 0 to 90 degree, that is oblique slip fault. So in deep slip fault, rake 90, strike slip fault rake, your rake is 0 degree, oblique slip fault rake is 0 to 90 degree. Then there is another three types of fault you can say, that is strike fault, deep fault, and oblique fault. So what is strike fault? You can see the strike of the fault plane, it should be parallel to the strike of the neighboring rock. So this is the strike of the neighboring rock, they are parallel to each other, that is called the strike fault. And if the deep direction of the fault plane, deep direction of the contour rock, so this is the deep direction of the contour rock or neighboring rock, it is parallel to the strike of the fault plane, that is called as deep fault. So remember, in case of deep fault, the deep direction of the country rock or neighboring rock should be parallel to the strike of the fault plane. So that is called as a deep fault. So this one is your strike fault. This one is your deep fault. And what is strike slip fault? So you have to consider the rake. If rake is 0, that is strike slip fault. If the country rock strikes and fault plane strikes are parallel, that is strike fault. Then deep slip fault where rake is 90 degree, but in case of deep fault, you have to consider the deep direction of the country rock, that should be parallel to the strike of the fault plane. So let's see the question. So it is given, strike of the fault is perpendicular to the deep of the bed. Strike of the fault is perpendicular to the deep of the bed. So It is given ki strike of the fault perpendicular to the deep of the bed. So this is the strike of the fault. This is the strike of the fault, and this is the deep. So this is the deep. This is the deep direction. So it is perpendicular to the strike. Remember, if bed strike and fault plane strikes, they are parallel, then the deep of the bed will be perpendicular to the strike of the fault plane. So the strike of the fault, if it is perpendicular to the deep of the bed, that indicates a strike fault. That indicates a strike fault. So it will be strike fault. Then strike of the fault is parallel to the deep of the bed, that is we have discussed, that is deep fault. Then net slip is perpendicular to the deep of the fault plane. So net slip, if it is perpendicular to the deep of the fault plane, that means it is your deep slip fault. If net slip parallel to the fault plane, it is strike slip fault. See, this is the net slip. So now the net slip, it is perpendicular to the strike of the fault plane. So it is deep slip fault, and here you can see the net slip. This is the net slip. It is parallel to the strike of the fault plane. Here net slip, it is oblique to the fault plane. So it is oblique slip fault. So let's see what will be the answer. It will be strike fault is perpendicular to the tip of the bed. It is strike fault. A is 4. There is one option, that is A is 4, B is 3rd, C is 1, D is 2. So answer will be A. Then throw of the fault. So I have discussed it. So throw of the fault, the displacement in vertical direction of the fault, that is called as your throw. Displacement in horizontal direction, it is heave. Next comes to plumose marks. So plumose marks, it is basically, remember, it is produced on the joint surface. The characteristic marking of a joint surface, where you will find these radiating lines, and these are your called as hackles, which is your indicates pause in movement. So plumose mark, it indicates the surface of a joint. Surface of a joint. So it is characteristic structure of joint surface. Remember, it is plumose structure. Come to next question. The outcrop of bed shows V closure in the same direction as the contour. So if the outcrop show V closure in the same direction as the contour V with an obtuse angle, consider the following statement. Bed is inclined, bed is vertical, bed is dipping in the upstream direction, bed is dipping in the downstream direction. So if bed show V closure pattern like this and contour show V, so let's consider, or let's check the condition of these things. So when contour produce V pattern, and if that deflects towards the higher elevation, that is called as your, that structure is called as your a valley. Contour deflecting like this. Okay, this is your suppose 200, 300, 400. In this case, it is called as your valley. If it is like this, then it is called as your ridge, which it deflect towards the lower elevation. So now, in any valley, when bed will produce a V, bed will produce a V, that means the bed is inclined. Bed is inclined. There are two conditions where it will not produce V. One, a vertical bed will not produce V, and in inclined condition, if the bed, deep of the bed is equal to the deep of the valley, in that case also no V shape will produce. So there are two conditions where no V shape will produce. Then V, whether it will point towards the upstream or downstream. So this upstream side where the V contour V always point towards the upstream side. You can see the V of the contour always point towards the upstream side. But the V of the bed, it may point towards the upstream side or downstream side. That depends. There is only one condition where V will point downstream, where bed dips steeply downstream side, where bed dipping towards the downstream side and it is steeper than the valley gradient. In that condition, only V point downstream. In all other conditions, V will point upstream. So, so here you can see V will point upstream, but it is more obtuse. V will point upstream, it is more acute, you can say, in case of horizontal bed. In case of inclined bed, it is more obtuse. So let's come to our question. The outcrop of bed show V closure. So if it is showing V, that means the bed is inclined. In case of vertical, it is not show any V pattern. Bed is dipping in upstream direction. Obviously, bed is dipping in the upstream direction. In the upstream direction, the V will point towards the upstream direction. So A and C will be correct. Bed is dipping downstream direction. If bed is dipping downstream direction, there are two conditions actually. So if bed is steeper than the valley, the V will point downstream. If bed is gentle than the valley, the V will point upstream. So here there is no such option ki A, C, D. So you have to choose A and C, because bed dipping downstream, it can point upstream, it can point downstream. You can see here. Bed dipping downstream, V point upstream. Bed dipping downstream, V point downstream. But when bed is gentler than the valley, V point upstream. When bed is steeper than the valley, then bed dips or V point downstream. So next question, the presence of conglomerate is indicative of conglomerate. So it indicates, remember, the presence of basal conglomerate or any conglomerate bed in a deposition always indicate an unconformity. Unconformity, where we have discussed key fault indicated by the presence of breccia, and like that, conglomerate indicates the presence of an unconformity. The answer will be unconformity. So this is all your structural geology question of CUET from 2022 to 2025. So this for today. So then the next video we'll discuss another chapter questions. So thank you.